Here is the next example. In this example, he's asking us to find V1, V3, I2 by using nodal analysis. So our step one is find all the nodes and then choose one of them as a reference node, right? So basically I have a node there. Since he already used V1, V2, V3, I'm going to use this as VA, VB, VC and VD. Okay, and I'm going to choose the bottom one as reference node as usual, compared to, similar to the other examples. If you don't understand, please review my old videos. I always choose the bottom one as a reference node because it's easy to be consistent. Another one is it's a good idea to choose a node where more elements are connected. So here, if you look at this, 1 2 1 2 3 4, these 4 elements are connected to the reference node. At VB also I see 4 elements. You can choose VB as a reference node too, but to be consistent I always choose the bottom one as a reference node. Now, do we need to apply KCL at VA? So if you look at VA, if there is a voltage source between VA and reference node, then we don't need to apply KCL. Because what kind of source is this? I'll tell you why. Because what kind of source is this? This is a current dependent voltage source. Whenever you see the rhombus, that rhombus indicates that that's a dependent source. Rhombus indicates the dependent source. If you have plus and minus, that indicates that that's a voltage source. And if you have multiplication I, so this voltage source depends upon the current, so it's a current dependent voltage source. If you have something like this here, that is a voltage source, but it is depending upon the voltage. That's a voltage dependent voltage source. Okay, so here I can tell, VA minus 0 equal to 5I2. I don't need to apply KCL. VA, I can clearly see VA equal to 5I2. Even though this is a current, say for example you end up with I2 equal to 2 amperes, VA equal to 5 times I2, so 5 times 2, still this is a voltage, 10 volts. You just take the number, don't worry about the unit. Okay, this VA is still a voltage. So VA equal to 5I2, that's equation 1. Are there any other nodes we can easily tell the voltage? I can clearly see there is a voltage source between VC and reference. So I can say VC equal to 100 volt. This is good, independent voltage. And same thing, VD equal to 0.2 times V3. Okay, that's also voltage source. So I have 3 equations. So this is my second, that's my third. Now I need to apply KCL at VB because I don't have any equation for VB. So apply KCL at VB. So at VB, apply KCL. So if I apply KCL at VB, I'm going to take every current is going out of the node because that's easy for me to choose. Since he has I2 there, to avoid confusion, I'm going to take every current as with the letter IA, IB, IC and ID. There are 4 currents. So IA plus IB plus IC plus ID equal to 0. So what is IA? IA, I can write it as VB. IA is the current flowing here. So current is flowing from VB to VA. That means VB is the high voltage. Okay. Is it really VB is higher than VA? We don't know at this point. Okay. But still, since I chose all the currents are going out, so VB must be higher than any other voltage. Any other voltage connected to that node. VB minus VA over 45. IB is nothing but minus. IB is going down. but this is a current source, that current is going up, so minus 0.02 V1 plus IC is nothing but VB minus VC over 30 plus ID is nothing but VB minus VD over 50 equal to 0. This is my fourth equation. Okay, let me simplify this offline. So before simplifying it, I have one more unknown here. That one more unknown is V1. Can we define what is V1? Look like I forgot to indicate that the V1 is given right here. This is V1, that's already given. So from here I can define V1 equal to VD minus VC. That's my V1. So everything I'm writing it down in terms of VA, VB, VC, VD. So that's our goal is V1, V3, finding V1, V3, I2. But when you're doing with nodal analysis, our goal is shifted to finding VA, VB, VC, VD. Okay, so every equation must be in terms of VA, VB, VC, VD. Okay, I also have I2. I can write I2 equal to, in this case, let me label this as fifth equation. I2 equal to, can I write this as VD minus VB over 50. This is my sixth equation. Another equation I need to know, V3. I can write V3 equal to VD minus VB, because VD has the positive voltage, VB has a negative voltage, so V3 must be VD minus VB. So this is my seventh equation. Now what I'm going to do, I'm going to substitute this fifth equation right here in equation 4, and I will simplify that offline. So here I substituted, here is the equation applying KCL at VB. So what I did, I substituted V1 value here, V1 equal to VD minus VC. Okay, now to eliminate the denominator in this whole equation, I multiplied this with 450. So once I multiplied that, I end up with this equation. Okay, and once I simplified it, I end up with this equation: minus 10 VA plus 34 VB minus 6 VC minus 18 VD. We already know VC equal to 100 volts because I have a voltage source between the reference and VC. So I found VC equal to 100 volts. So I substituted that, ended up with minus 10 VA plus 34 VB minus 18 VD equal to 600. Now here I have an equation, VD equal to 0.2 V3, but at the same time V3 equal to VD minus VB, because in the given equation here is VD, here is VB. Okay, so VD minus VB must be equal to V3. So I substituted that equation. I end up with the relation between VD and VB, end up with VB equal to minus 4 VD. Okay, again at VA equal to 5I2, that's the first equation we solved. Okay, now I substituted I2 equal to VD minus VB over 50. Okay, so I2 is nothing but the current flowing in this 50 ohms resistor. Okay, so what is this I2? I2 must be V3 over 50. So that's what I did. V3 is nothing but VD minus VB over 50. So VD minus VB over 50, I end up with a relation between VA and VD. This is my 10th equation. Okay, so now 8th, 9th, 10th, I substituted this equation 9 and 10 in equation 8. Okay, I end up finding VD value as minus 3.77 volt. Once I have VD, I substituted VD value in equation 10, found VA, and substituted VD value in equation 9, found VB value as 15.08. Okay, I think it's look like I did it in a long way. we should have substituted, instead of VA, VB, we should have substituted V1, V3. So we will end up finding V1, V3, I2 without finding VA, VB. But anyway, to be consistent with other examples, I found all the node voltages. Once I found the node voltages, I can find any other parameters in the circuit. So I found V1 as minus 103.77 volt, V3 as minus 18.85 volt, I2 as minus 0.377 ampere. Thank you.